Okay, ladies and gentlemen, to continue what we were talking about, adding vectors is simple, but it must be done from the component form. Adding vectors is simple, but it has to be done from the component form. Yes? You're adding the x's and adding the y's. It's really not hard. Okay? Same thing with scalar multiplication. A scalar is just a number. And if all I'm doing is multiplying that by 5, it's truthful that you're just multiplying the 2 by 5 and the 3 by 5, and you get a new vector, 10, 15. It's not, you should be fine with multiplying and adding. Or subtracting, since subtracting is adding a negative. But I need you to understand what the pictures mean. When you have two vectors that you are adding together, you really need to watch this, write this down, something. When you add two vectors together, you connect one vector from the end of the other one. So let me zoom in on this picture right here. So we're traveling along, singing a song. Get to here. Yeah. Side by side. What is that from? I don't know. I can't remember. It's some musician or musical thing I remember from my youth. When you add two vectors, you basically connect one to the tip of the other. So for instance, you see that I drew kind of like a new x and y axis at the end of vector u. And then you are measuring vector v from that new starting point. What that creates, folks, whoa, what is going on with my LCD here? Okay, all right, I'm not sure. Hang on, girl. Okay. The vector u plus v goes from the original origin location to the tip of the second vector. Okay? So, when you add two vectors together, you get this particular shape. Now, here's my next question, does that vector have a component form? So you think so? And you are correct. That new vector where you're adding it, now, we call this vector the resultant vector. Resultant. Now, if you look at this other picture, you can see the two original vectors, u and v. Do you see how it almost looks like a parallelogram? And so u plus v reminds me of the diagonal of a parallelogram. That's really what's going on here, folks. Now, where do we run across situations like this? If I'm flying an airplane and I am, let's say I am vector v, but the wind is pushing me, and the wind is vector u. If I don't redirect myself, instead of landing, so I'm going, this is why airplane pilots have to know what's going on, because if they push themselves this way, so they can land there. Because the wind is going to be pushing on them as they're up in the air. They have to take that into consideration. If they don't, they're not going to end up where they want to end up. And there'll be a lot of unhappy people. And it'll take us 2 hours to get back to where we were supposed to go. So what do you think u minus v would look like? So, based on my picture, if u goes like this, where is minus v going to go? which direction does minus v head in? So if v, so minus v, actually mine's even not a very good looking minus v. Let's get better at that. It's not the greatest. If v is the purple one headed to the right into the first quadrant, minus v would be going into the third quadrant as you suggested. So if I attached that to the end of this picture, I would get something like this. So the blue one right here would be u minus v. Now, so what if the pilot of the airplane isn't taking into consideration that he has a very strong headwind in front of him that's pushing him? He better take it into consideration or he's going to end in the wrong place. So, u minus v is that blue one down there. So that's why we talk about attaching them at the ends, right? From one tip to the next. If u is the original one that you see right there, the blue one, what do you notice about 2u? It's double. It's twice as long. But what is the same? The direction is the same. 2u does not go in a different direction than u. If it's a speed, folks, it means that I have twice the speed, but I have the same direction. So, half u is obviously the same direction, but just half as much. And then negative 2u, they show you, is twice the original length of u and going in the opposite direction. Hopefully that makes sense. Okay, so we need to practice with a few of these. Shouldn't take us too long. You should take about maybe 40 seconds to answer these 3 questions. It won't be long for you to... $3.10. Sorry, that's a bad looking 10. Yep, you're just distributing. Well said, well said. Are there any of these that we need to go over? I'm pretty sure you're good with your distributive property and then adding your x's and adding your y's. Anything not making sense? Okay. How long do you think a unit vector is? 1. Excellent idea. That's right. A unit vector is a vector that has a length of 1. Now, take any vector v that is not the 0 vector. Right? What do we call the 0 vector? Okay, in the world of science, they'd call it a black hole, right? Sucks everything in. It's a vector that has no magnitude whatsoever. I'm not even sure which direction 0, 0 goes. It's just a dot. I'm like, it is, dare I say, one of the most pointless things. Yeah! And that was awesome. I guess in truth it would be one of the most pointful things. Yes, they get worse, folks. All right, now, this is telling me what to do to change any vector in the universe into a unit vector. What does it tell me to do? It tells me, now for those of you who don't know what I'm talking about here, this this symbolism right here. I know you think it means absolute value bars, but it means, just so you're aware at parties, the magnitude of V. Okay? Yep. Liddy fresh, almost, right? Liddy fresh, almost, right? Okay. Were there any people there with that? Did they? No, Liddy, not lady. Seriously. No, I know what you mean. Okay. Was there anybody there with? Is it their kicks were dripping? Was there anybody there with their kicks were dripping? I do. You should have said weird flex, but okay, but you didn't. Okay. I'm learning. Okay, so what is the magnitude of negative 3, 2? What is the magnitude of that vector? Whoa, whoa. Hey, she knows she's using the Pythagorean theorem. I don't know if you guys know that, but she does. Negative 3. Oh, man, what am I doing right? Yeah, you were thinking the right thing. That's right. Mm-hmm. It's a feisty crowd today. No, who's Gibby? From iCarly. I hated that show. When my kids were younger, yes. No favorite character. I didn't like the show. Okay, so negative 3, 2. Come on, folks. Although I did hear a reference, they mentioned. I didn't hear it. I was in the back bedroom, but I heard the television this morning, and they were talking on the news about Dora. Okay. Okay. All right. So the newscaster said, "Sniper, no sniping." I was like, I just lost it. I was like, first of all, where is there a sniper in Dora? Okay, that's a little bit violent for Dora. Okay, then you want to whip out the map there, and check out where the sniper is, Okay, perhaps she had night vision in her backpack. No, Swiper was the character. It wasn't the fox. Swiper, no swiping, because Swiper would always steal things. Okay, never mind. I lost it when she said that. Okay, I need to know, folks, what's the magnitude? What's the magnitude? Come on. 9 plus 4 is the square root of 13. Nicely done. So to make this a unit vector, according to what they're telling me, I take 1 over radical 13, and I multiply it times, negative 3, 2, not negative 3, 2. Okay, now, personally speaking, I would leave my answer like this. Yes. Now, could I write it like this? If you have to do that on Math Excel, okay. They will not allow you, that's right, I do remember that. On the Math Excel, they will not allow you to leave it in Staley form. Okay. So MXL wants you to look at it like that. Yeah, Mixel. Okay. You don't have to rationalize that, folks.
Wait, how do you get the 1 on top?
Well, folks, if you want to divide, look at what it says right here. If you're dividing, isn't that the same thing as multiplying by 1 over that? It's that whole division is the same as multiplying by the reciprocal. Waiting. Yes, 1 over whatever that number is. Okay, now. This notation does show up, so you need to be aware of it. Down here, we're going to get to something called a linear combination. Now, don't get scared, folks. This is really basic and easy. It's based on these two vectors called standard unit vectors. Okay, so which way does 1, 0 go? Which way does 1, 0 go? To the right, 1 unit. Okay, that's the vector 1, 0. Which way does 0, 1 go? North, 1 unit. Okay. Yes. Praise Pythagoras.
That word is banned during Lent.
Okay, now. All right. Okay. During Lent? Really?
Yes, it is actually.
Okay. Is that the same stuff I pull out of the drawer? Okay, so the standard unit vectors are listed right there, and we use the letters I for 1, 0 and J for 0, 1. So the component form, look at the component form, A, comma, B, can be separated into two different vectors that are added together. A, comma, 0 and 0, comma, B. Notice that they're going to pull out the A and the B using the distributive property in reverse. And then they can substitute for 1, 0 and 0, 1 the letters I and J. So in other words, this is not really that hard. The component form is going to look like this in linear combination form. Basically, you just take the two components and slap an I and a J on them, folks. It's really not that hard. I know that, they show you the correct looking math right there, where they separate it, they pull out the A and the B, and then replace. But, by and large, that's what we're getting at. It's just your A goes with I. Oh, let's go with alphabetical order. A, B, I, J. X, Y. Okay? Not artificial intelligence. Okay. We've talked a little bit about direction. They're using other terms like resolving the vector. Usually that's just finding your components. If V has some direction, so in other words, if I know the direction of the angle, then I can find the components. I need to know two things. What two things do I need to know? One of them is the direction. What else would I need to know to find the X and the Y? What's that notation tell us that we just talked about a few seconds ago? Those absolute value bars mean magnitude. Resolving a vector is a fancy phrase for, if I give you the direction and the magnitude, can you come up with the components? See, at the beginning of this lesson, we were talking about, here's the components. You find the magnitude and direction. Now we're going the other direction. We're giving you the magnitude and the direction and saying, hey, can you come up with the components? It's really not that hard, folks. Does it make sense to you that cosine goes with X and sine goes with Y? Okay, so that's real similar. Cosine goes with X, sine goes with Y. Throw a little mag V in there.
Oh, it makes so much dollars now.
Yes, I'm glad. Glad it's making more than just cents.
Well, it's your decision.
Of course it's going to be funny. My administrator even said we have some characters in this room, which I was not disputing. Okay, we got some serious characters in here. Yes. Yes, no names, no names. Okay. Okay, now, Find the components of the vector v with direction, angle 115, and magnitude 6, using no technology except to approximate the exact trigonometric solutions. Ooh. Okay, now I'm going to show you two different ways that I could do this. Okay, we should be able to tell you. So you know the magnitude of the vector. You can see it from the picture. What is it? 6. So we know the magnitude is 6. So we've got 6 cosine 115. And what do we have for the y? 6 sine 115. This is, if I don't have technology. Now, could I do something with half angles? Probably not, because that's 230 degrees, and I don't know what 230 is. Could I do something with addition or subtraction? Maybe. But truthfully, folks, I'm not trying to cram more into this chapter based on the last one. So I'm probably not going to whip out the half angle formula or the cosine sum and the cosine and the sine sum formula on this. Okay? That's in your language extra. Right? Would that be gassing it, or is that too much? No? Okay. So I would like this as your answer. Now, what do you know about the cosine of 115? Is it positive or negative? It is negative. So what will this be? Will this be positive or negative? That'll be definitely negative. Here, I'll write that word out since that sign won't make any sense to you. Okay? All right, how about this one? Do you think this one's going to be positive or negative? That is positive. Because we went to the left, and cosine is the x value, so we know that the x value will be negative. All right, now, folks, I want to show you one more way to do this before we leave. What if we looked at this triangle right here? The angle inside here is a 75-degree angle. What if instead of using cosine 115, what if I use 75 and over here? So we'd have 6 cosine 75 and 6 sine 75. There is going to be one major problem with this particular answer, although this is another way to handle it. What do we know about 75 degrees? What do you know about the x and the y? Both are what? They're both positive. But you clearly can see from the picture that the x is negative. So to do this correctly, I would have to make the choice to put a negative sign on that first x value. Now, I don't care which way you would do it. The cool part about this one is it will automatically tell you that it's negative. But I don't care really which way you handle it. Oh, did I do that wrong? It's 65, isn't it? Oh, well, thank you very much. Thank you for yelling at me earlier. Sorry, I was kind of loud and on a roll. Good thing we're getting it changed in the video, so all the people at home can not be mad. You don't? Oh, that's sad. Okay. Because if you wanted to look at the right triangle, instead of using the 115, if you just wanted to use the right triangle, you could do it that way. You don't have to. I said there's two different ways you can handle it. So either way. We start at 31.